Alright, today we're going to be looking at how to determine Q or K from a series of reactions. The expression Q or K, if the reaction is at equilibrium, is determined by dividing the products by the reactants. Now, when you're given a series of reactions and their K values, you must be able to manipulate the reactions to suit the final reaction and find the ultimate K value. To do this, we need to learn a few rules. First, we're going to look at multiplying. When you multiply a reaction by a coefficient, the K value must be taken to the power of that coefficient. So if I had a K of 6.72 times 10 to the negative third, and I were to multiply the reaction by 2, I'd need to square this K value. The next rule we're going to look at is reversing. When you reverse a reaction, you must take the inverse of the K value. So if I had a K of 3.2 times 10 to the negative 32nd, I would have to take the inverse of this. And that is also equal to 1 over 3.2 times 10 to the negative 32nd. The next rule is division. When you divide a reaction by a certain value, we'll call that value n, you must take the nth root of K. So if I were to divide a reaction by 6, I would need to take the 6th root of this K value. So I just go ahead and do that and put a little 6 here. The last rule we're going to look at is how to find the overall K value. And when you need to find the overall K value, you multiply the individual reactions' K values. So if I had a K of 3.7 times 10 to the negative 11, and another K value of 6.4 times 10 to the negative 5th, I'd have to multiply these two K values together. Let's look at an example. So up at the top, we're given two reactions that are supposed to add up to the bottom reaction. So the first reaction is HF goes to H plus F minus, where the K value is 6.8 times 10 to the negative 4th. Our second reaction is H2C2O4 goes to 2H plus C2O4 2 minus, where the K value is 3.8 times 10 to the negative 6th. And once we're done manipulating it, it needs to add up to 2HF plus C2O4 2 minus goes to 2F minus plus H2C2O4. So if you look at the bottom here, there's a 2 in front of the HF. So we need to go ahead and multiply this whole reaction up here by 2. So that'll give us 2HF goes to 2H plus 2F minus. And our K value will then be squared. Now, if you look at the bottom reaction, you'll see that H2C2O4 is a reactant over here. However, in the bottom reaction down here, it's now a product. So we're going to go ahead and reverse this reaction. C2O4 2 minus plus 2H plus goes to H2C2O4. And then the K value has to be inverted, 3.8 times 10 to the negative 6th to the negative 1st. And that is also equal to 1 over 3.8 times 10 to the negative 6th. So now we can go ahead and add these reactions together. So the H pluses cancel out because they're an intermediate step. So then we go ahead and add it up. That'll give us 2HF plus C2O4 2 minus goes to 2F minus plus H2C2O4. So that matches our bottom reaction. So now all we have left to do is multiply the two K values together, and that will give us an overall K value of 0.1217. So that's it for that problem. Here's our final K value over here. And here's our final reaction. Let's look at another example. You guys can go ahead and pause this video and go ahead and restart it whenever you're ready to see the answer. Alright, welcome back. So, our first reaction was N2 plus 1/2 O2 goes to N2O, where the K value is 2.7 times 10 to the negative 18th. Our second reaction was N2 plus O2 goes to 2NO, where the K value is 4.7 times 10 to the negative 31st. And that needs to add up to our final reaction of 2N2O plus O2 goes to 4NO. So, if you look over here, what we did first was we reversed the first reaction, but we also multiplied it by 2. So that gives us a K value of 2.7 times 10 to the negative 18th to the negative 2nd power. Now the second reaction, all we had to do was double it. So that gave us 2N2 plus 2O2 goes to 4NO. So we just took this K value of 4.7 times 10 to the negative 31st and we squared it. So then we just multiply those K's together, and that gave us a final K value of 3.03 times 10 to the negative 26th. So there's a summary on how to get the ultimate K value from a series of reactions. I hope that helped you guys.